You know that colorful chart from science class. Well, I want you to forget everything you thought you knew about it, because today we're going to see the periodic table for what it really is, one of the most elegant and powerful documents ever created. Let's dive in.
So look at this. This isn't just a boring collection of squares and letters. No way. This is a map. A map to pretty much the entire known universe. I mean, every single thing you can touch, see, or even breathe. From the stars way up in the sky to the phone right there in your hand, it's all built from the elements on this chart. It's like the ultimate ingredient list for reality.
Okay, so to read any map, first you have to understand the legend, right? The key that tells you what all the symbols mean. So we're going to zoom in on the very first element, the one sitting right up there in the top left corner, hydrogen. Each and every box on this table is like a detailed identity card for an element. Let's break down what hydrogen's ID card is telling us.
All right, the first and honestly the most important piece of information is this number right at the very top. For hydrogen, it's 1. This is its atomic number, and you can think of it as the element's unique fingerprint. It tells us there's exactly 1 proton in the nucleus. If it had 2, it just wouldn't be hydrogen anymore. That one number defines everything. It's the element's soul.
Next up, look at the number down at the bottom, 1.008. This is the atomic mass. The simplest way to think about it is that it's the average weight of a single atom of that element. It gets a little more complicated, but for now, just know it tells us how heavy the element is.
The rest of the card just fills in the essential details. You've got the big H, which is the element symbol, kind of like a universal nickname scientists use everywhere. Below that, its full name, hydrogen. And then you see we even get info about its electrons. Now that little number is the secret to why elements are grouped into families, which we're going to get to in just a minute.
Okay, so we can now read a single square. Awesome. Let's zoom back out and really appreciate the brilliant organization of the whole map. We'll start with the horizontal rows. Think of these as the lines of latitude on our elemental map.
In the world of chemistry, these 7 horizontal rows are called periods. And as you move from left to right across a period, you're basically on a journey where the elements change in this really clear, predictable pattern. Let's just look at period 2 as an example, which starts with lithium and goes all the way over to neon. The fundamental rule for the periods is just so beautifully simple. Every time you take 1 step to the right, you add exactly 1 proton to the atom. That's it.
So, we start period 2 with lithium, which has an atomic number of 3.
Take 1 step over and you get beryllium with an atomic number of 4.
1 more step and you get boron at 5, and so on and so on. See, it's this perfect logical progression that gives the table its incredible power.
All right, so we've traveled across the map's latitude. Now let's look at its longitude, the vertical columns. And these, well, they tell a completely different story. These 18 vertical columns are called groups. And if the periods tell a story about change, the groups tell a story about family. Elements in the same column all belong to the same chemical family. Seriously, think of it just like that. Elements in a group might have different weights, kind of like family members of different ages, but they share a core personality. They all react to the world in very, very similar ways. For a really great example, let's jump all the way to the far right side, to Group 18. This is the family of noble gases. Every single element in this column, helium, neon, argon, you name it, shares the family trait of being extremely stable and unreactive. They're kind of the cool, aloof introverts of the chemical world. They just like to keep to themselves. So the really crucial thing to get is how these two systems, the horizontal periods and the vertical groups, work together. By combining them, we can pretty much crack the code of any element on the map. So let's break it down. The periods, the rows, show that gradual, predictable change. But the groups, the columns, that's where the real magic is. Elements in the same column have a similar electron setup on their outermost shell, and that's why they behave so similarly. One is the journey, the other is the family you belong to. And this is where the map becomes so incredibly powerful. Because knowing an element's coordinates, its row and its column, doesn't just tell you its address on the map. It tells you its personality. You can predict its properties, how it'll bond with other elements, whether it's going to be super reactive or totally stable, all just by seeing where it lives on the table. It's an absolutely astounding predictive tool. So, we called this a map, but it's really more than that. It's like a chemical GPS. It doesn't just show you the layout of the elemental world, it actually predicts the road ahead.
It guides scientists through the millions of possibilities that make up our world. And believe me, we've only just scratched the surface of how to read this incredible document. Every color, every section, even those two mysterious rows floating at the bottom, they all hold more information. So now that you have the key, what secrets do you think you'll find?